Hi everyone. Today I'm going to be teaching you lesson 12-5, which is modeling with respect to recursive and explicit formulas. So you've really learned all of these formulas that we're going to use today. We're just going to be talking about word problems having to do with them. So let's just talk about a little summary of the formulas you've learned so far. So at the bottom of your page, I'm just going to write them down so we can talk about them a little bit here. Oops, hang on one second. Okay. So we've talked about arithmetic sequences, and those are sequences with an adding pattern. And then the amount that you add to get from one term to the next is called the common difference. So there's an explicit formula for an arithmetic sequence, and that's a sub n equals a sub 1 plus n minus 1 times d. So the a sub 1 is my first term. The n is the term number, and the d is the common difference. And the a sub n is the ending term. Okay, there's also a recursive formula. So in a recursive formula, we state the value of a term in the sequence. Usually we use the first term, and then we relate how we get from the term that we have to the term that we want. So in an arithmetic recursive formula, since there's an adding pattern, we say we take the term that we have, which is 1 before our ending term, and we add the common difference. So we also talked about geometric sequences. Oops. And they have a multiplying pattern, which we call the common ratio. So there's an explicit and a recursive formula for a geometric sequence as well. So the explicit formula is a sub n equals a sub 1 times r to the n minus 1. So the a sub 1 is the first term. The n is the term number. The a sub n is the ending term. And the r is the common ratio. Oops. Okay. There's also a recursive formula for a geometric sequence. We usually state the first term or any term in the sequence, and then we relate the term that we have, which is a sub n minus 1, to the term that we want by multiplying by the common ratio. Okay. So if we take a look at our notes, some of them we're going to ask you to submit without going over them on the video, and others we're going to go over together. So please take a minute to read through the warm-up question, pause the video, and answer it. Okay, so let's take a minute to go over the warm-up. So we know that we're talking about an arithmetic sequence because they're talking about the number of seats per row increasing at a constant rate. So that means there's a common difference between the terms. So this is an arithmetic sequence. Okay. We know that there were 31 seats in row 3, so row 1, row 2, row 3 has 31 seats. Then we have row 4, row 5, and row 6 has 37 seats. So we want to know how many seats are in row 20. So I'm going to use the explicit arithmetic sequence formula. So I'm just going to kind of bring it down over here. So a sub n equals a sub 1 plus n minus 1 times d. So in order to plug into this formula, I need to know two things. I need to know my d value, and I also need to know my a sub 1 value. Okay. We already know actually what n is, because if they want to know how many seats are in row 20, n is going to be 20. Okay. So let's start by figuring out what the common difference is. So to figure out the common difference in an arithmetic sequence, you want to find the slope. So I'm going to make a little chart. And I know that in row 3, there were 31 seats. And in row 6, there were 37 seats. So common difference is really just the slope. So change in y, 31 to 37, that would be a 6. Divided by change in x, 3 to 6 would be a 3. So my slope is a 2. So my common difference is a 2. So this value right here is going to be a 2. And lastly, I want to find the first term. So now if I know my common difference is a 2, that means going forward, I would add 2. So if I wanted to fill in the pattern, I could, right? I start at 31 here in row 3, so if I added 2, I would get 33, then I would add 2 and get 35, and then add 2 and get 37. So if I want to work backwards now to get to row 1, I'm going to subtract 2. So I'm going to start with the 31. When I subtract 2, I get 29. Then I'm going to subtract another 2 and get 27. So my first term in my sequence would be right here. It would be term 27. So if I want to know now how many seats are in row 20, I'm going to plug into this formula. So I'm going to say a sub n, or a sub 20 rather, because I know. Equals my first term value, which is 27, plus 20 minus 1 times my common difference, which is 2. So I would get 27 plus 19 times 2. And when I multiply that out, let's see. So I have 27 plus 38. That's going to give me 65. So the correct answer here should have been choice 1. Okay, so like I mentioned before, some of the notes you're going to be filling in yourself and submitting, and some of them I'm going to be going over with you. So number 1, we're going to talk about together. And then I'm going to have you answer number 2. As a your turn question. Okay. So let's take a look at number 1. So this is a little bit different than we've seen before because they're telling us at week 0, the sunflower is 3 inches tall. So this is week 0, it's 3 inches. Now it grows 2 inches a week. So that means at week 1, if I added 2 to 3, I would get 5. And then I could continue it, right? Week 2, if I added 2 to 5, I would get 7. Okay. So we need to know which of these formulas actually work and would generate this sequence. So this is sort of a trial and error. So first I'm going to try the first one. So I'm going to look at my formula. I'm going to say, okay, I have f of n equals 2n plus 3. So I know at week 0 here, my plant is 3 inches tall. So for n is the week number, I'm going to plug in a 0. So if I plug in a 0 anywhere I see an n, I want to know if I would get back a 3. And I do. Now I'm going to try plugging in a 1 because we know at week 1 we should get back a plant that's 5 inches. So where I see an n in this formula, I'm going to plug in a 1 now. Oops. And I get back a 5. So that works. And then I could try 2 if I wanted. Anywhere I see an n, I'm plugging in a 2. So I get 4 plus 3, which is 7. And that works. So choice 1 is good. Now I'm going to try choice 2. Change colors here. So now we're going to look at this equation and see if it works. So I have f of n equals 2n plus 3 times n minus 1. It's a little hard to see, sorry. Let me make it a little bigger. Okay, so now I'm going to try the same thing. I'm going to plug in 0 because at week 0 I should get back a 3 if this equation is correct. So 2 times 0 plus 3 times 0 minus 1. So I get 0 plus 3 times negative 1, which is negative 3. So at week 0, they're saying my plant would be negative 3 inches. So this choice does not work. Now I'm going to look at choice 3. So choice 3 is a recursive formula. We talked about that a little bit earlier. And they're telling me here that at week 0, my plant would be 3 inches tall. So that looks good. And then they're telling me to get from the term that I have to my next term, I would add 2. So that's correct. So the correct answer for this question should be choice 4. Okay, so I'd like you to pause the video and try question 2. Okay, let's take a look at question number 3. So when you're looking at question number 3, they want to know which is it going to be a recursive formula to determine the cost of a 3-ounce letter. Okay, so first we have to figure out if it's arithmetic or if it's geometric. So let's take a read through it. So the cost to mail a letter was 49 cents up to 1 ounce. So that means A sub 1 should be 49 cents. So looking at my choices, I could actually select the correct choice already because there's only one choice that says that the A sub 1 is 49. But let's keep reading. So every additional ounce costs 21 cents. So that means that you have an adding pattern of 21 cents per ounce. So the correct answer should be choice 1 because, again, this is the arithmetic recursive formula. This is the term that you have. Then you add 21 cents, and that would result in the next term. Okay. We're also going to talk about number 4 together. So if you look at question number 4, the thing with this one is they're asking for a recursive formula. So right away, you should be able to eliminate choice 1 and choice 3 because they're not recursive formulas. They're not stating a term in the sequence. Okay, so if you look at choices 2 and 4, you can see that they are stating that the 0 term is 75,000. So that means when they bought the boat, the cost of the boat was 75,000. Okay, so now we need to know what's happening here. So when I look at this, it's saying that the boat is depreciating by 8% a year. So when you see a percentage, that means that you're talking about a geometric sequence or you're talking about a multiplying pattern. So we have to now figure out what the multiplying pattern is. In other words, what the common ratio is. So to figure out the common ratio, the formula is either 1 plus the rate if you're growing or 1 minus the rate if you're decaying. So depreciation means decay. So to figure out the common ratio, it's 1 minus 8%. But remember, 8% has to be written as a decimal. So that's 0.08. And if you forgot that, you could go back up here and say, okay, 8% is 8 divided by 100. That's 0.08. So my common ratio is 0.92. So the correct answer for question number 4 should be choice 4. Because this equation is saying you want the term that you have, you're multiplying it by the 0.92, my common ratio, and that's going to give you the next term. Okay, so questions number 5 and 6 are going to be your turn questions. So that means you're going to submit those with your notes for today. And we're going to look at question 7 together. And then number 8 will be a your turn question. Okay, so let's take a look at number 7. So we want to know which represents the range of the function. So the first thing that you have to remember is the range is the output or the y values. Okay, so they're telling me here that my first term is 2. So I can get rid of choices 3 and 4 right away because they don't have a first output value of a 2, right? So here are my output values. So we know our first term is a 2. Now we have to figure out how to get to our next term. So we have to look at the pattern. So let's see what the pattern is describing. So this is saying, this is the term I have. So we're going to take the term I have, multiply by -5, and then add 2 to it. So let's try that out. So the term that I have so far is a 2, right? My formula is saying multiply that by -5 and then add 2. So if I did that, I would get -10 plus 2, which is -8. So the second term, my second output should be -8. So the correct answer for number 7 is choice 2. But I could keep going, right? I could say, okay, I have -8 now. That's my second term. Now I'm going to follow the pattern, which says take the term that you have, which is -8, multiply it by -5, and add 2. So if I did that, I would get 40 plus 2, which would give me 42 as my next output value. And I could continue from there. Okay, so before you continue, you might want to refresh your memory again about the arithmetic sequence formulas and the recursive sequence formulas. And remember, with the recursive sequence, I'll write it under here. The a sub n minus 1 is the term you have, and the a sub n is the next term. Okay, and in an arithmetic sequence, this is the d value is your common difference. That means how much you're adding to get from one term to the next. And in your geometric sequence, the a sub n minus 1 is the term you have. The a sub n is the next term. And the r value is the common ratio, or your multiplying factor. Okay, so you should be completing questions 2, 5, 6, and 8, and submitting them today on Canvas in addition to the notes that you took for the questions that we went over on the video. Okay, thanks everybody.